Cool. So you're going to be very familiar with UObjects because this is how you deal with actors and components, and they're all UObjects. And the UObject system is basically garbage collection in C++. And it's much nicer than having to use T-shared refs everywhere. It's much nicer than having to think about like manual memory management. And it's also, it's better than the T-shared refs because if you think about like actors and stuff, you typically want the actor to be able to control its lifetime, right? Like the actor calls destroy, it wants to go, or destroy actor, it wants to go away, it wants to remove itself from the game world. You don't want some T-shared refs somewhere keeping the actor around after you want it to be removed from gameplay, right? So it's important that actors and those sort of things have control over their own lifetime. At the same time, you don't want the actor to, destroy itself and then for there to be a bunch of garbage references all over the place because you don't have any memory management and now you're getting crashes because things still reference this old actor. So instead we have garbage collection through the UObject system. We can construct a UObject through the use of UObject. So let's make an actor. This is not really how you would normally make an actor, but I'm illustrating the new object usage. So this creates an actor. This doesn't actually set an outer, but you probably want to. Usually in like my game code, usually for like temporary stuff, I'll just like get the player controller, right? Oh, it's not available. Really? And the game mode base doesn't have player controllers? That's surprising. Anyway, I'd usually just like get the player controller or whatever and use that as the outer for like a temporary. Keeping in mind, of course, this is garbage collected, right? So like unless you actually put this somewhere, the garbage collector is aware of, this is going to get garbage collected, right? Because there's nothing holding on to this actor, and certainly nothing holding on to this actor after this scope exits. So how do we make references to actors and other UObjects? Well, we will have UProperties. So if I do like act, and now I have a UProperty. I have a property that is going to track an actor on the game mode base that we've like got going here. And by default, because we've just declared a UProperty, this isn't visible to blueprints at all. We can make it visible to blueprints using, I guess it's blueprint read write or editable. I'm blanking on the stuff now. I know it's edit anywhere. Blueprint visible. I'm going to blank on stuff. Yeah, so you can make these properties visible to blueprints, and then you can access them from blueprints and do what have you. But what I wanted to talk about is, so we've got our actor here. But yeah, I thought it was blueprint read write, but the IntelliSense wasn't showing me blueprint read write, and I was like, I'm pretty sure it's blueprint read write. Yeah, so blueprint read write if you want to make it read write. Oh, good point. Somebody says you got to move it out of private. That's probably what it is. Edit anywhere. So we can make it visible to blueprints and let them edit it that way. But I'm not going to do that right now because we're just going to deal with some C++. So because these properties are garbage collected, we might set them in game code to be like an actor. We might set them in blueprints to be an actor. But if we want to actually use them and we're not sure, well, if we want to use them, we basically have to check if they're valid, right? So we have to go use the isValid function. We can't, notice how in like T-shared refs and T-shared pointers, right? We called the isValid on the pointer, right? But here we don't have this because this is just a raw C++ pointer. We don't have any implicit methods on it, right? So instead, there is this global function called isValid where you can pass it a UObject pointer and it will tell you whether or not that UObject pointer is still alive according to the garbage collector. Even if it is, then you can use it just like you would any other pointer, right? You can just get the world, for example, from get the world from this actor. You can, so we sort of touched this on this before. If you are doing just raw classes and you want to store a reference to an actor, for example, then, you know, we could make our test class and set it that way, and then we could store our test class wherever we want. And then when we want to use this weak pointer, we can go, okay, you know, is it valid? If it is valid, we can then call .get, and then this will give us back that a actor pointer, which we can then just use as a normal pointer. So if you need to access, access UObjects from non-UObject code, you'll want to be using T weak object pointer to keep those, not to keep the references around, but to like keep the references while it's valid, so that you can use it. Something else you can do is, so every UObject, including actors, the game mode base, everything, all inherits ultimately from UObject. And UObject provides a way of having extra references that are not tracked outside UProperty, and it's called add referenced objects. I need to go look up the syntax, the actual signature for this real quick, so I can remember what the parameters is. I think it's something like this. I could be wrong. All right, I'm not going to go to it. There is a function called add reference objects, I believe you can override. And so if you have a bunch of actors or UObjects or what have you, and it's not tracked with a UProperty, like maybe it's not in a T array, maybe it's in some other sort of specialized container that the garbage collector can't handle, you can actually iterate through those objects and tell the garbage collector when it's tracking references for this game, like in this case, for this game mode, you can be like, oh, hey, actually, I am referencing all of these other pointers. You should consider them as if they were referenced through UProperties. And so that's how you can sort of keep additional random UObjects alive that are not necessarily stored in the typical containers that the UObject system is aware of. If you're doing low-level stuff, you have the same thing as FGC object. That will give you, where is it? Yeah, here we go, add referenced objects. Yeah, I knew I was right. I must have been thinking about FGC object. You can also do this here and say, oh, you know, notice we don't have to use the weak object pointer now. We can just put a go there. Let me just be like, oh, cool. I'm going to go collector.add referenced object, act. And now that actor object will be kept alive whilever this instance is around. Because I believe FGC object will like, yeah, see, it's kind of going to register itself with like the global garbage collection system and say, hey, this raw object, this low-level object wants to keep UObject pointers around. You can call add reference objects to find out what it's referencing, and then you obviously implement add referenced objects to tell it, to inform the GC that, hey, I'm keeping all this stuff around. So hey, that's how you can do UObjects and how you can reference them and how you can interact with a garbage collection system. Now we're going to do some fun stuff. We're going to peel back the magic of UProperty. Because if you look at this, I think, okay, cool. We got garbage collection, like Unreal gives us garbage collection in C++, right? It knows that this UProperty is this field on this object. But then, like, how does it know that, right? Like, how does Unreal get the metadata to know that this particular field in this particular class contains a pointer to a UObject, that we should track it and that we should clear it out when it's done? This is not a special, this is not like T-shed pointer where we've got some, you know, type wrapping here. This is just a raw C++ pointer. If the garbage collector doesn't go and set this to null, it will just continue referencing old garbage memory for as long as it does, right? Like it will just continue forever. So the garbage collector has to know that this field exists on this class, or on instances of this class, and know that when this actor like destroys itself and is removed from the world, that this should get nulled out. So like, how does that work? The answer is generated body. So let's see what generated body looks like. Again, remember how we're doing all of that stuff about the preprocessor and how it's going to be handy later? This is the part where it's handy. So for every for a UObject file, you will notice that at the top here we have this .generated.h because we've got UObjects in here. This is mandatory if you put uClass on it and you try and compile and you don't put the generated.h, it will complain at you. That's going to be very important. If we look at what generated body expands out to, we can see that this is a lot of preprocessor macros, but it's going to basically combine a macro called current file ID, an underscore, the current line number, right? This is what it's the special underscore line means the line number that this is on, so it'll be 13, and then the suffix underscore generated body. And now what we're going to do is going to open this file. Cool. So now we're looking at this generated file that the Unreal build process has generated for us. When you build your project, Unreal runs a tool called the Unreal Header tool, and that will scan all of your headers for uClass, generated property, UProperty, and it will generate metadata. It will build a list of like all the fields that are in all of the classes that are tracked as like UProperties, and it will generate this .generated.h file. And you can see at the top of this generated.h file, where is it? There should be a current file ID somewhere. Yeah. So it creates this current. It defines current file ID to be this particular constant, which you can tell it's like test project, source, test project. It's basically the path for the file, just a bit nicer. And if we look at this, where this is used, we can see it's used in a bunch of places here. And I think this is going to be slightly off because I adjusted line numbers. Yeah, so line number is 11, actually, the last time that it was generated. You'll notice that when I added spaces, added new lines at the top of this file, IntelliSense started complaining. That's because there is no define yet for 13. These are all for line 11. And when we build the project again, it will basically, Unreal will regenerate this header file, right? And then it will put in underscore 13 as a thing. Actually, you know what? Let's just build it right now and let's demonstrate that. So as we build, hopefully we will see this update live. There we go. Magic. See how it changed the line number? So what it's doing is it's tying, it's mapping this macro to an expanded version that includes the file name and the line number. And then in the generated header file, it's actually defining all of these macros that is based on the file name and the line number. And then it's expanding that out to all of these additional like fields and constructors and metadata that's required for UObjects to work. So for example, you know, this is where we get, oh, I know I've seen it somewhere. So we like declare class, and then declare class macro comes back into here, and you can see this is where, you know, this is where, for example, the UObject system makes the equals operator and the copy assignments and move constructors. It makes all of them private because you don't want to use them with UObjects. It's where it gives you the static class function and all of these other helper functions that are really useful for UObjects. It basically does it by mapping this preprocessor across from generated body into this generated header file. If I go open containing folder, there is one more file we need to look at. Because you'll notice here that, yeah, we've added some extra fields to the class, but we haven't really defined, we haven't really registered anything with the metadata system, right? Like we've got these extra fields and these extra functions on the UObject, but how does it at runtime know this metadata? Where does that come from? So if we go and open our project, right, and I'll just open up this thing, you'll notice we've got this .generated.h. We've also got this .gen.cpp file. If we open up this, we will find more generated code that it will add for us. And so this is a CPP file. Unreal includes it in the build. We obviously just don't see it on our Solution Explorer there, but it is a CPP file. it gets compiled like your CPP files. It includes the header, and this is where we get all of our implementations. Now, bear with me. You don't have to understand what all this does. Even I read through this and I'm like, blah. But what we can do is use our knowledge of what we're actually declaring in here to kind of figure out what's going on. So we've got this act property, and if I search for act, oh, that's actually a really bad property name because it's going to match all the actor stuff. Let's call it blah. That's not going to match anything. Again, if I build, you'll see that this is going to like live change. Yeah, there we go, blah. So we can find all of the things that reference the blah property by just searching for blah in here, and we can see that we're getting, you know, a bunch of static data is being defined in here. We're getting like, you know, if with metadata. Hey, look, here's a bunch of metadata about the blah property. The blah property is defined in this file. So if you go into Unreal Editor and you like double click on like a blueprint node or like a C++ class, and then it opens Visual Studio and it just opens it magically to the file that happens to contain the blueprint node in it. This is how it figures it out, because it sticks the metadata about what file it's in inside this generated CPP file. And then that allows the editor to just go, okay, it's in this file, I'll open Visual Studio up here. And so we get a bunch of others. I mean, this is generated code. So like it is not designed to be read. It's designed to sort of just like get data into the system. We can see here's our class specification. So this is where it's basically telling Unreal Editor what the class looks like. We can say, okay, the property pointers, if you look at this prop pointers thing, right? We'll go up here. Where did they go? I know there was somewhere. Word wrap is getting us. Okay. So this is where prop pointers is. This is a list of all the U properties in the class, right? It's an array. We've got some nice fancy like wrapping classes that are internal that make this a bit nicer. But you know, here's a reference to the property. And then in our class semantics, in our class metadata that's being passed in, we're passing in these prop pointers. And so we're sort of building up and seeing how this is sort of starting to flow into the engine, right? But what actually accesses this data, right? Something has to know where class params it sits, right? Right, something has to know. Like if we look at where does any of this happen, right? And you'll notice like nothing's actually calling this function, right? How does Unreal Engine know where to call stuff? Like we have to call the function to still get the registration code to happen, right? This is due to a thing that is how constructors work on global variables in C++. And guess where we're going back to? We're going back to Godbolt. Oops, that's in a different tab. Huzzah, we've come full circle. Cool. So let's think about, I make a type. I'm going to say, you know, public ftest. We make a constructor for this type. I'm going to include standard IO so that I can use printf. I'm going to printf hello world. And now I'm going to give, which can have a main function. It's not going to do anything. Oh, I'm going to make sure it returns 0. Now we're going to declare a global variable. Now global variables are not a thing in C#. I mean, the closest you're probably going to get is like a static read-only like field in a class. But C++ and C lets you declare global variables, right? I can just put an int here. And this is a global int that exists in the entirety of the program. There was exactly one field called A. What happens when we do ftest A? And we are now using our class that has a constructor that has to run as a global variable. Like, where does that run, right? Notice how our program is outputting hello world, even though we haven't actually used ftest in main at all, and yet it actually prints out hello world and it runs that code. This is because when you have a constructor on a global variable, and that constructor does work, the C++ compiler will generate an initialization function for it called static initialization, or in this case, it's internally called static initialization destruction. And you can see that this is calling the constructor it's calling the ftest constructor on this global memory that we've reserved for this work. And then you can sort of see here, like more, this is calling the static initialization. Notice main doesn't call this, right? So you're like, okay, but where is this called? And the answer is it gets called by the runtime loader for like the library runtime loader that the operating system runs when your application launches. So before, or it's probably actually called by the C++ library, because the C++ library, standard library, will actually take the application start and jump into your main function and do a bunch of initialization setup. The point is that this happens before main runs, before your application actually starts up, and it allows global variables to be initialized according to whatever custom logic you want. And now we come back to these little custom types that we've got here. See how these are all like declared as global variables? Well, the constructors of these global variables run when your DLL or your module loads at startup. And that is what allows it to be registered with Unreal Engine's like global UObject system. Be like, hey, by the way, I have registration data for UObjects here. Stick this in your UObject system, and then later on when you need to look at it, it'll be available. And we didn't have to actually do an initialization anyway. This metadata just flowed straight in as soon as the module was loaded as soon as the module was loaded, like the game module was loaded into memory and starts running. So that is how UProperties work and how we get this, what otherwise might seem like magic, right? How it actually flows into Unreal Engine. It's not magic. It's a bunch of preprocessors and the way that constructors work on global variables. And that's how all of that flows in. Do I have anything else? Okay, I can also go into, I could cover how the garbage collector actually works. How are we doing for time? We're at 3 p.m. and I believe we are, look at the schedule, 3 p.m. Okay, so we have delegates and callbacks now. So I won't go too much, I won't cover how the garbage collector internally works. Basically, well, I'll give you a quick 30-second overview. Basically, we've just registered all of that UObject data in through the global constructors, and then the garbage collector goes through, it has a list of what's called roots. So objects can be added to the root if you have, I know I said I wouldn't go into it, but now I'm going into it. So you can add a UObject to the root list. You can also remove it from the root list, remove from root. And what this means is that when the garbage collector runs, it iterates through all of the things that are in the root list. And then from all those things that are in the root list, it then goes off to all of that metadata, that UProperty metadata, find all the related things that it then needs to like also track. So it goes all the way down from all the roots. And that's how it discovers basically everything from the root. And so in the normal game lifecycle, the U level, which is part of the U world sort of setup, the U level contains all the actors, and the U level is the root. And so what happens is the garbage collector goes, oh, hi, I've got the U level in the root. It goes and then looks at all of the actors in the level. And then that's how it tracks all of the actors in garbage collection. And, so on from there. One thing I will point out with this add to root, remove from root stuff is this is not a reference count, right? If you call add to root 3 times and then you call remove root once, it's removed from the root, right? It's not a stack. It's just on or off. So that's a gotcha to watch out for if you happen to use these functions. If you need to use them, it's pretty rare, but I've used them for putting UMG widgets into tracking UMG widgets in the garbage collector, like across worlds, because you can, like, well, not necessarily across worlds, but like without necessarily having an actor owning the UMG widget. I just add the UMG widget to the garbage collector root, and that's how I keep it alive for as long as the non-UObject kind of low-level C++ needs it. All right, and that's it for UObjects and how that works. Someone asks in chat, used it for the same thing, but only because there were sometimes Lambda callbacks from HTTP requests that fire after a world change happened. Always thought using add to root was a bit hacky though, and curious if there's a better way. Yeah, I don't know of a better way. I just use add to root basically in my solution for the UMG widgets. Yeah, I don't know of a better way of doing it. I think you can. I think there is root. Yeah, there's a function called isRooted. So you can, even though it's not a stack, you can be like, hey, is this already in the root? And then you can skip calling add to root and remove to root and let something else manage its life cycle. But there's not really, it's not really a stack. Maybe you could use t-strong object pointer though. I haven't tried this, but if you wanted to keep like a UMG widget, that's not the base UMG widget, but UWidget is what it is. If you want to keep a widget around, maybe that's a better way than add to root. Another person says, I found that UMG widgets persist to seamless travel because their outer is persistent, being game instance by default. Why would that happen? I mean, it's weird because outers shouldn't affect garbage collection. Yeah, look, that is some weird behavior that I have also seen, right? Remember how I was talking before about how like I just make the player controller like the outer for a bunch of temporary stuff? Because if I don't, it just like gets garbage collected before I can assign it to anything. I have seen that as well. I will admit I don't quite understand the semantics of why outers can extend the lifetime of things, even though the outer itself does not directly reference it. I don't have an answer for you on that one. If somebody figures it out, let me know on Mastodon, because I would also love to know the answer to that question.